Hi guys, today we're looking at finding the area under a curve using integration. Alright, so far, right, we've been in doing integration. We've learned that when we integrate, we need to add a constant c because we might never know what that constant is. Because of course, when you differentiate a constant, you get zero. So if you integrate the function, you want to take into consideration the possible constant might exist, so you add c to your integral, right? However, with definite integrals, we are able to integrate a function between 2 points and find the precise value of the integral. And in that case, there is no need for a constant or unknown term. Alright, so this is what you need to know. The area under a curve between 2 points can be found by doing a definite integral between the 2 points. To find the area under the curve, you have to integrate and evaluate the integral, right? Alright, let's look at a question. It says find the area of the region bounded by the curve y equal 1 over 2x plus 1 cubed. The lines x equal 1 and x equal 3 and the x-axis. So the curve is bounded by the lines x equal 1, x equal 3 and the x-axis. We are asked to find the area of the region bounded by this curve. Okay, alright, so you need to know that the area on the curve is equal to where a and b are the limits and y is the function, right? In this case, we're going from 1 to 3 and the function is 1 over 2x plus 1 cubed, right? So first thing we need to do is, so we can rewrite this. So that's gonna be 1 to 3, and this can be rewritten as 2x plus 1 to the negative 3. So we're taking the 2x plus 1 cubed out of the denominator, so the power becomes negative. Alright, so now we can integrate. When integrating, you know that the power is increased by 1. So negative 3 plus 1, that's negative 2, divided by that same integral, and also multiplied by 1 over the derivative of what's inside, which is 2. And we have these rectangles. We have these square brackets to show the bounds. So we're going from 1 to 3. Alright. So let me write back that. Maybe a little meter. 2x plus 1 over 2 times negative 2 is negative 2, and the limit is from 1 to 3. Alright, so let's simplify this. That's gonna be negative 4 down there, right? If we should actually take it out, it would be 1/4. Negative 1/4. to multiply. So then take out negative 1/4, we're left with 2x plus 1 to the negative 2 power, right? And again, we're evaluating from bounds 1 to 3. So that's gonna be negative 1/4. Let's erase that mark. There's gonna be negative 1/4 upper limit to 2 times 3 plus 1 negative 2 minus 2 times the lower limit which goes back down to negative 1/4. So 2, 3, 6 plus 1, 7, that's 7. So negative 2 would be 1 over 7 squared, which should be 1 over 49. And then that's 3. So that's 1 over 3 squared, which would be 1 over 9. And when you get your calculator and simplify all of that, it should give you 10 divided by 4, 49, or 49, 41. So this implies that the area under the curve is 10 over 4, 41 units. You don't have to write as a decimal, you can just leave it as a fraction. Alright, so that question is through. Pause. Okay, let's look at another example now. It says find the area of the region bounded by the curve y equal cos x minus 2 sin x and the lines x equal pi by 6 to x equal pi by 3. Remember, you have to integrate y dx, right, from a to b, where a and b are the limits. So that's gonna be cos x minus 2 sin x dx from pi by 6 to pi by 3. Alright, so let's integrate. Seeing that it is sum and difference integration, we just integrate each part. So when you integrate cos x, we get sin x, and would have integrated the x, which would be, we would have multiplied by the derivative, which would be 1, plus 2, when you differentiate sine, you get negative cos. So the negative cos becomes plus. So that's 2 cos x pi by 3 pi by 6. Let us substitute the values, right? So that's going to be upper limit minus lower limit. That's going to be upper limit minus lower limit. So that's sine pi by 3 plus 2 cos pi by 3 minus, these are different color, minus sine pi by 6 plus 2 cos pi by 6. Sine of pi by 3, that's root 3 over 2, that is 1, minus sine of pi by 6 half plus 2 times root 3 over 2. Removing brackets to get root 3 over 2 plus 1 minus half minus 2 minus root 3. 2 cancel 2 right there, so minus root 3. So that's gonna be half times 1 minus root 3. This is how we get half times 1 minus root 3. 1 minus half is half, right? So we have root 3 over 2. So that is gonna bring us to half minus root 3 over 2, which is equal to, factor out half, we have 1 minus root 3. And we can leave it as this. Here, equal half times 1 minus root 3 units. Okay, thanks for watching. I hope you're able to hear the audio clearly, and I hope you would have learned something from this. Good night.